Dear friends, in the last class, we completed the analysis of the truss from a definition to checking of whether it is perfect or imperfect. And now in this class, we would like to discuss about the method of joints and method of sections. Initially, we need to know some fundamentals about method of joints and what are the conditions, how we need to proceed, right? Level maximum. Now here you see two-force member concept. Two-force member means it is not a complete new law. Now you can see in our older discussion, you see here. So these are the two supports. There are some members in the truss. 1, 2, 3, 4, 5, 6, 7. Right? So up to this, the members are okay. Joints are some joints A, B, C, D, E. In the last class, we checked whether this is a perfect or imperfect. Okay. Now in this class, how to determine the force that is generated by each and every member 1, 2, 3, 4, 5, 6, 7. Okay. So by application of the external force, here what are the external force? Loading at this joint D, F1, loading at the joint E, that is F2. Direction may be different. It may be horizontal, it may be vertical, or it may be an inclined load like this. Okay. Suppose I'm applying another load here. See the second diagram. I'm applying inclined load F3 at an angle some 30 degrees. Right. So at the joints, I can apply the load, right? Due to this application of the load F1, F2, or F3, whatever it might be, these members, whatever the members of the truss we have, each and every member will have some force induced. Force will be induced inside the member, right? Every member. So AD is a part. So there will be force created in AD. There will be force created in AB. There will be force created in DE. Every member of the truss, as many members you have, in every member, there will be some force created, right? Now, we need to find what is the force that is created in AD, force created in AB, like this, okay? Suppose I'm taking this simple triangular truss, right? So forget about the support, forget about this, whether it is perfect or imperfect, okay? Now, the application of F1 and F2, right? Due to these two, there will be some force created in A, AB. Okay, I will give the name here C. Right. So ABC is a triangular truss. Now, F1 and F2 are external loads. Now we need to identify induced force in AC, induced force in BC, induced force in AB, right? Now, two force means in every member, there will be force created in two directions, right? Either it is tension or compression. Okay. So what is tension and what is compression? Suppose I am taking a bar like this, right? Suppose there is a force both outside, right? That means we are trying to elongate it. It is called tension. Okay. That means we are making more stiff, right? And in the reverse, suppose I am applying the force in the opposite direction towards the body, right? It is called compression. Compression means we are applying in opposite direction to the body. Tension or compression. Now you see, in the AC, there may be a tension, there may be a compression. In the BC, there may be a tension or compression. In AB, there may be a tension or compression, right? But to our luckiness, the analysis of the truss, you can consider initially either tension or compression, no problem at all. So for our normal analysis, I will always take compression, right? Why compression is to be considered initially? It is for our advantages. Suppose I am taking joint A, okay? Joint A. In the bottom right side, I am taking the figure joint A. Because this is hinged joint, HA will be horizontal reaction, RA will be vertical reaction. Suppose there is the force created in AC will be, I am thinking here compression, right? Here also in BC also, I am thinking compression. AB also, I am considering compression. That means the force will be created inside AB 2 times, from A in this direction, from B in this direction. So I am writing what are the force that is created inside your member, each and every member. So the force created in AB, I am naming it as FAB. From A, it will be in the right direction. From B, it will be in left direction. What about the force created in BC? A compressive force is created from B, it will be in left direction. From C, it is down direction, F, B, C. Similarly, in AC also, F, AC, from A it is upward direction, from C it is downward direction, F, AC, same force in the reverse direction. So, there is a compression assumed here, there is a compression assumed here, there is a compression assumed here. But remember one thing, always compression will not be there. There may be a tension created in AC or BC or AB. Then how can I know it? In my consideration, I am taking compression. I am thinking it is compression. If I am correct, the force will become positive, right? Suppose the force is negative, that means my compression assumption is not correct. So once I am getting the negative, so I need to confirm that tension is created inside a member. Suppose FAC is some minus. So I need to clarify that FAC will be tension force, right? So initially, for our analysis or for our benefit, we need to consider all the induced forces are away from the joint, right? So that we can resolve the forces FAB, FAC, FBC, right? All these forces very clearly, okay? Now we shall check. There are some conditions where we can calculate the forces inside the members. Forces inside members, there are some conditions. By applying these conditions, we need not calculate some of the forces in the members, right? We need not calculate. There are some shortcuts, okay? So some forces inside the members may become zero. There may be a condition, right? So first of all, you need to identify, is there any zero force members inside, right? And is there any symmetrical forces, right? You see in the diagram, suppose I will remove F2, okay? Suppose I will remove F2, right? So the force created because of the joints supports A and B. Truss is also equally 60 degrees, same length, equilateral triangle. Suppose only one force that is vertically down F1, then we will assume our one calculation is correct. FAC will become equal to FBC because of symmetry. When loading is symmetrical and the truss is also geometrically symmetrical, automatically all the members on one side of the section, right? Now you see the section I can make vertically like this. So whatever the vertically left hand side, the same is on the right hand side, except the hinge supports and roller support. So whatever the geometrical truss design above the supports, it is symmetrical to the left side and the right side of the section. And the loading is along the section. Right? Then whatever the forces that are in the left direction will be the same in the right hand direction. Okay, that is one condition. And now how to find the zero force member? We will check. Initially, we will check the condition. So this is called the two force member concept, right? Now in the method of the joints. So how to proceed for the method of joints? So the name itself is indicating that the analysis of the truss will be completely dependent on joints only, right? As many points are there, that means as many joints are there, each and every joint free body diagram is considered. So consider the free body diagram of the entire truss and applying the equilibrium, you know very well. Find the support reactions. The first point is already you know very well. How to calculate the support reactions with the different types of loading, that is point load, UDL and UVL. I think we completed many problems, uniform distributed load and uniform varying load, point load and their combination along with the moment. We applied the equilibrium conditions sigma fx0, sigma fy0 and sigma m is equal to 0 to find support reactions. So after finding the reaction, what I need to do? You know the external loads, you know the support reactions, but inside there are members of the truss. Now I need to calculate each and every member, right? So to calculate, consider the free body diagram of the joint from the truss at which not more than two members with unknown force exist. That means not more than two members with unknown force. That means only two unknown forces in members. Okay. That means we need to start at a joint where we are having only two unknown forces. Obviously, the third one will be known force. What is the known force? It may be a load or it may be reaction. Okay. It may be a load or it may be a reaction. Right. So if that particular joint load is applied and the reaction is also there, no problem at all. Okay. So the third one, either load will be there or reaction will be there. Okay. And two unknown forces only exist. So if it is only the reaction, so third one, so three forces will be there. So joint will be in equilibrium. Otherwise, we may apply the Lami's theorem or we may apply the third condition, that is sigma fx0 and sigma fy0. So initially you need to assume the member to be in tension or compression by simple inspection and applying conditions of equilibrium. For your benefit, it is my suggestion, always you be with compression, so that each and every joint we are having the force will be outside. Okay, it is very easy to transform into its components f cos theta, f sin theta and other things, right? So it is my suggestion to have compression. You may assume tension, no problem at all, right? And the fourth one, the assumed sense, that means either tension or compression can be verified from the numerical results. See, A positive answer indicates that sense is correct. So initially I will assume that compression, if I am getting positive answer, so compression is correct. Suppose I am getting a negative answer, so the sense shown on the free body diagram must be changed. That means it will become tension, right? Now you need to select new free body diagram of the joint with not more than two unknowns in a member and repeat the points 3, 4, 5 for complete analysis. That means suppose I am having the four joints A, B, C, D, right? Suppose the C is having only two unknowns, start with the C. So there will be one calculation in C, right? So that calculation you transform to the another joint D, okay, or B or A. So initially, just for example, I'm saying first C will be analyzed, next A will be analyzed, next D will be analyzed, next B will be analyzed, like that. So one by one, you complete all the joints. So free body diagram of all the joints will be considered. You calculate everything. That means this problem is a simple problem of resolution of the forces and applying the conditions of equilibrium. Sigma fx0, sigma fy0. You know very well. Okay. Now you tabulate the answer representing the force member, magnitude of force, and their nature. So it is called the finally force table. That means you need to write a table, serial number, what is the force, AB, AC, BC, DE, FE, like this. And what is the amount of force that is induced in it, either tension or compression, like this. Okay. Okay. Few minutes back, I told you there will be some conditions where you are having some members will have zeros, right? So there is no force induced. Now you find the first condition, identification of the zero force member simply by inspection. So without any calculation, right? Now what is the condition? If any joint is identified without external force acting on it, such that the joint is formed by three members and two of them are collinear, then the third non-collinear member should be identified as zero force member, right? Now you check here. So I am checking joint A, right? Suppose it is formed by HA, RA, right? Here it is in the B, it is RB, okay? And is there any collinear force here? Okay, HA, and here I am having FAE, and here it is I am considering compression, so FAC. Okay. Now I am identifying joint A. So this is joint A. What are the forces? F, E, C, and this is HA. This is RA, and I am having FAE. Okay. Here itself FAE. Right? Three forces are in three different directions. So A is not applicable. Right? Now you see the example, joint E. You take the joint E. Okay. There are some collinear force F, AE, and F, EF, F, DE, and F, CE. So at the joint E, I am having 1, 2, 3, 4 forces are there, right? But we are having only two collinear forces, and the third member is CE. Fourth member is DE. So 4 members are there. We can't do anything. So is there any 3 member at C? You are saying 1, 2, 3, 4. 1, 2, 3, and 4. Not applicable. At D, you see 1, 2, 3, 4, 5 forces. Not applicable. Now you go for the joint F. Look at the right side diagram. At the joint F, I am having FEF in one direction, FBF in one direction, and FDF in other direction. So it is a 3-4 member joint. At this joint, you are having two collinear forces. One is EF and one is BF. Right? These two are collinear. What about the third one? It is perpendicular to this. Of course, whether it is perpendicular or in some other direction, right? Suppose I am having other direction. It is F, BF, and this is F, EF. Suppose in some other force, like this, it will be there. Suppose it is F, DF. It doesn't mean that it should be perpendicular. Okay. So these two are collinear. These two are collinear. So they are okay. What about the third one? So there is no force induced in it. So without any calculation, you conclude the force in the member DF is 0. Okay. Is it clear? This is one condition. Right. Next. So this is one example. You can identify the inclined force. Now you see all the joints. Just to check each and every joint. Is there any 3-4 member joint is there? Now you can check in the left hand side. F 1, 2, 3 members are there, and it is the hinge. So F is not applicable. D 1, 2, 3, 4 not applicable. G 1, 2, 3. Okay, there may be, right? So we will check G. Next E 1, 2, 3, 4 not applicable. C 1, 2, 3, 4 not applicable. What about B 1, 2, 3? Okay, B can be checked. A 1, 2, 3. A can be checked. Okay, right? Suppose at G, suppose RG, the force in the member GE, the force in the member GE, suppose FGE, considering GE, suppose RG is equal to FGE, the force induced in this member FG, that means a vertical bar, it will become 0 if RG is equal to FG, obviously. Okay. But now you can see here, joint B, you can check it. FBD, FAB, they are collinear. So they will be equal. Third member FBC, so it will become obviously 0. Right? Now, there is another condition. Look at the truss. Where is the loading? The loading is at C, the loading at E, right? But what about the members CD and DE? They are unaffected by the loading, right? Because the loading is completely beared by the joint C and E. So no impact on the joint D. When the joint D is not affected, CD and DE, they are not at all responding to the other loading conditions. So if any joint is formed by two non-collinear members without any external force acting on it, suppose there is a force, so I am inducing some other force, F3, then condition will not apply, right? Because D is a loaded one, C is a loaded one, F2 is a loaded one. Suppose F3 is not there, okay, then you see the right side, FCD and FCE, they will become 0, okay? And one more thing, suppose I forgot this condition, what I can do, right? After your calculation, you are going to declare that the force in that particular member will become 0. Even if you continue the calculation, you will get 0 only, right? Now, third condition, if any joint is formed such a way that the four forces are acting under collinear in pairs, then each of the collinear forces are equal. So in any joint, just the example is joint E. So what are the forces collinear? FCE and FEG are collinear. So they are acting in a line. So this inclined line. So FCE and FEG are collinear. And the load and the force induced in the member EF. So F2 and FEF are, these two are collinear. So a joint is formed. So obviously F2 will become equal to the induced force FEF and FCE will be equal to FEG, right? Like this, okay? And earlier I told very clearly, if a given truss is symmetrical in the geometry as well as in the loading and supports, then support reactions are symmetrical and forces in the members on half side of the symmetric is equal to forces in members on the other half. Now you look at the diagram about your vertical, change the color, mix color, red, okay. Now you see, about this vertical section, whatever that is in the left side is equal to the loading or support, whatever it might be on the right hand side. Okay. So here left side, I am having one reaction, RA. Here it is the reaction, RB. Here, even though I am having HA reaction, because there is no opposite horizontal reaction, HA will become equal to 0. So I am having RA and RB, equal reaction supports. What about the loading left side? At D, I am having 10 kilonewtons down. At H, at the same distance L, same downward loading 10 kilonewtons, right? What about upside loading 20? It is exactly in the middle, right? Suppose I will apply some other load here at C, 10 kilonewtons to the left side. Symmetric to the other side, suppose at the G, I will apply another load, 10 kilonewtons in this. Now you see, all are symmetric, right? Then the force induced in one side of the member is equal to other side of the member. Suppose I am calculating FAC, right? Symmetric to this, what is on the right side? BG. So if I calculate FAC, I need not calculate FBG. Same thing opposite side, mirror image, right? So you calculate CD, need not calculate force in the GH. You calculate in the AD, need not calculate in BH. You calculate in DF, need not calculate in FH. You calculate in CE, you need not calculate in EG. But vertical member, you must calculate only one side, FEF, right? So this is one condition. So half of the calculation will be, you can skip off, right? If it is symmetric, right? Suppose I am saying here, instead of 10 kilonewtons, I am making 20 kilonewtons here. Okay, all symmetry has gone. All symmetry has gone, right? You need to have the symmetry in the supports, in the loading, in the geometry, everything. If any one is deviated, we need to calculate each and every force, right? Now we'll check one problem. Okay. So this analysis will have method of joints and method of sections. Now we'll go to the method of joints. So each and every joint is given free body diagram and we need to solve joint by joint. Okay, finally we are showing the force table like this. Now we'll check the find the forces in all the members of the truss. Right? So in this problem, it is called cantilever beam. Cantilever means in one side only we are having the support, that is fixed support, right? And in analysis of the trusses, we are having one advantage. If the beam is cantilever beam, you need not calculate any support reactions. So without support reactions, you are able to calculate all the force members. Okay. Now we'll do one thing. Okay, joint C. Okay, we'll change the color. Pointer up, change the color. Okay, I will take it as blue. Okay. So what are the external loadings? 40 kilonewton at C, 40 kilonewton at D, right? Okay. Now I need to calculate the forces in the members AB, BE, BD, ED, CD, and BC. So 6 forces, right? 6 force members I need to calculate. Now I am considering initially all are compressive, right? Okay. Now you go to the BC. So inside, right? So there is a force from B, F, BC. There is a force from C, that is FBC. It is compression the member BC. Okay, right. Next, CD. There is a force from D, FCD, and there is a force from C, same magnitude, direction different. FCD is compressing the CD member. Again, BD. There is a force from B downwards, that means inside, FBD, and from D, it will be upside FBD. Now you go to D, from E, it will be FDE. From D, it is left side, compression of the member, FD, DE. Now you go to the BE. So from E, it will be upside, FDE. From B, it will be downside, F, same force, DE. Now what about your AB? This is FAB. This is FAB. Okay. Clear? Now you see, there is a joint. Okay. Any force member is 0. Okay. Now what is the loading? At D, 1, 2, 3, 4. No chance. C. Okay. There are the 3 forces, but no collinear, not applicable. B, 1, 2, 3, 4. 4 forces, not applicable. Okay. Forget about A and E. Right? There the members cannot be 0. Right? Okay. So by visual inspection, there is no 0 force member. Okay. Is there any collinear forces and equal and opposite? Look at the junction D. Here FDE is there, FCD is there. So FDE and FCD will become equal. And again FBD and 40 kilonewton. FBD will be equal to 40 kilonewton. Right? So before that, you calculate starting each and every free body diagram. So which free body diagram I need to select initially? Only 2 unknowns should be there. Now look at joints B, D, and C. At B, I am having all unknowns 4. At B, I am having 3 unknowns. At C, I am having 2 unknowns, 1 known diagram, known force, right? Now I will consider joint C. Okay. Now at the joint C, what are the forces? On the left side, I am having FCD. On the left side, with an angle FBC. At the bottom, I am having 40 kilonewton. Now, what is this angle? How much angle it is? It is theta, right? What is the value of theta? What is the height BD? BD is equal to 3 meters. Because BD and AE is 3 meters. Parallel to this, BD is there. So, BD also 3 meters. What about CD? 3 meters. So, what is tan theta here? Tan theta is equal to 3 by 3 is equal to 1. So, my angle theta is equal to 45 degrees. So this will become 45 degrees, right? Now you need to apply either Lami's theorem, because the junction or the joint C is in equilibrium with three forces only. You can apply Lami's theorem or you can apply anyone. Sigma fx0, sigma fy0, right? Sigma fy is equal to 0. All the forces on upside is equal to all the forces on downside. So what are the forces on upside and downside? Okay, I will do one thing. I will check it. One second. I will open this in another tab. Okay. Now you see this. This FBC, I will convert into two components. FBC on the left side. This will become FBC cos 45 degrees. In the vertical, FBC sin 45. I will increase the canvas. Okay, I will write here FBC sin 45 degrees. So once it is transformed, so this angular force is, it can be removed. Now I can apply sigma fx0, sigma fy0 very happily, right? So sigma fy0, what is the force on the upside? It is FBC sin 45, downside 40 kilonewton. So FBC sin 45 will be root 3 by 2. No. Sorry. Okay. So I will erase this. Or otherwise, I will write the equation directly. FBC sin 45 degrees is equal to 40 kilonewton. So from this, FBC is equal to 40 by sin 45 degrees. Okay. Now what's the value? So I will go to calculator. 40 divided by sin 45. So initially I will go to sin 45. Okay, sin 45 is 0.707. And I need to take 1 by x of it. What's the value? 40 by sin 45. Okay. So this is 1 by x into 40. What is 56.56. Okay. So FBC will be 56.56 kilonewton. Right? So I got FBC. Now sigma fx is equal to 0. I need to apply sigma fx 0. So what are the forces? FCD and FBC cos 45. Both are in the same direction, right? Now FCD is equal to minus FBC cos 45 degrees. So minus 56.56 cos 45 degrees, right? So what's the value? Earlier we calculated it multiplied by cos 45. So I will go start again. So cos cos 45 equals to cancel 45 cos. So what is the function? Cos 45 multiplied by 56.56. Okay, into 56.56. How much? 39.99. Okay, almost is equal to 40 kilonewton. So FCD is also equal to 40 kilonewton, but it is in minus, right? Now come to your earlier one. So FCD is minus 40. So the direction will be like this. Earlier I told you clearly, if my assumption is wrong, I will get negative. So here I assumed that FCD will be left hand side. So I got FCD is equal to minus 40 kilonewton. That means FCD will be reverse. So the actual one will be not like this. This will become FCD is equal to 40 kilonewton. Right? Or otherwise you can do one thing. Here FCD is equal to minus 40 kilonewton. So FCD is known to you. According to our condition, FCD is equal to minus 40, it will be equal to FDE. So this is also equal to 40. What about FBD and 40? These two are collinear and opposite to each other. So FBD is equal to 40 kilonewton, right? Now I know about FBD. I know about FBC. Now go to the joint B. Go to joint B, right? So we will take the joint B separately. I will open somewhere again in Paint 3D. Okay. I will increase the canvas. Okay. Now you can check it. Yes. This is joint B. On the left side, I am having FAB. In this side, I am having FDE. On the downside, I am having 40 kilonewton. And in this direction, I am having FBC. What is the value of FBC? 56.56. Right? So now coming into this. So FBC is known to you. FBC is already known to you. FBD already you calculated. Now I need to have FAB and BE. Right? AB and BE. Okay. Now in our earlier calculation, what's the value of BC plus 56.56? Okay. So at the joint B, you apply the condition of equilibrium. What is the condition of equilibrium? Sigma fx is equal to 0, sigma fy is equal to 0. Now I am erasing the other things to calculate easily. So these unnecessary things I am erasing. Okay. Right. Now I will apply sigma fx is equal to 0. That means all the forces on the left hand side is equal to all the forces on right hand side. Right. Now what is the angle actually? Here it is 45 degrees. Here also it will be 45 degrees. right? So it is better to convert the force into two components. Okay. So I will do with more clarity. So downside, I'm having 40 kilonewton, right? And these 56.56, it is having the component 56.56 sine 45 degrees in the downside, 56.56 cos 45 degrees over B. So this one. So this force FB, there's a network problem here. It's stucking. Okay. Okay, here it is moving. Right. I will open here and I will FAB. Okay, we'll do one thing. I will take the snipping shot and I will open again. Okay, I will open again in Paint 3D. Right. Okay. Now it is. Okay. Okay, right. Okay, now come to this FAB. It is in horizontal direction, FAB, like this. Now, what about FBE acting at 45 degrees to the horizontal? Now, here it will have the component on the left hand side, FBE cos 45 degrees, and on the downside, along with this, FBE sin 45 degrees. Okay. Now, you know about sigma fx0, sigma fy0, right? What are the forces on the y direction? Just look at 56.56 sin 45 down, 40 kilonewton down, FBE sin 45 down. When all the forces are down, FBE will become minus. Okay. So from this, I can calculate FBE. So FBE sin 45 degrees is equal to 56.56 sin 45 plus 40. So obviously, FBE, after finding this value, I need to sin 45. So I can find the value easily. Okay. So shall we do it? 56.56 multiplied by sin 45 plus 40 divided by sin 45, right? So how to find in the calculator? I will show you. Calculator. 56.5 multiplied by 56.56 equal to almost 40 plus 40 plus 40. So this is nearly 80. Okay. Divided by sin 45. Something happened. Okay. We remember the value sin 45 sin 45 is 0.707. I will take 1 by x multiplied with 80. So 113.13. 113.13. So FBE value will become 113.13 kilonewton, but it will be in minus. Okay. So FBE will be known to you 56.56 cos 45 in this direction. and FAB, right? Now, FBE cos 45 plus FAB is equal to 56.56 cos 45. Now, I will write the equation at the top by arranging the other one. Okay, I will write the equation FAB plus FBE cos 45 degrees is equal to 56.56 cos 45 degrees. So then what is FAB? 56.56 cos 45 degrees BE. Okay, I will substitute directly. Minus of minus 130 will become plus. So 113.13 FDE into cos 45, right? So 56.56 plus 113.13. So 56.56 plus 113.13 equal to 169.69 into 0.707. So 119.97, right? So FAB will be equal to 119.17 kilonewton, right? So in this way, all the forces in the members will be calculated by taking free body diagram of each and every joint and solving in our regular method sigma fx0, sigma fy0. Okay. Thank you very much. In the next class, we will discuss about method of sections or method of moments. Okay. Thank you very much. If you like this video, please like, share, and subscribe. Thank you.